Okay, so a little bit about myself so you know who's speaking at you. I got my undergrad in cell and molecular biology, so I'm a biochemist at heart. I fell into brewing in Asheville, North Carolina. I eventually became a shift brewer at Bearded Iris Brewing in Nashville, Tennessee. We brewed almost exclusively IPAs and New England IPAs, so a lot of time was spent dealing with hop creep. I eventually was promoted to manage the cellar quality and sensory of the brewery. And if you know about hop creep, it affects every single aspect of my job. I eventually became so obsessed that I decided to focus all of my brain power on hop creep. And so now I am at UC Davis, almost done now with my PhD there, uh, where I've done a lot of work on hop creep. I've also done a little bit of stuff with Russian River, kind of consulting with them and Vinny throughout this time too. So for today, I will start with giving an introduction to hop creep and define exactly what it is. I will then go into the three experiments I did in grad school, talk about the new components of hop creep, and then I hate giving recommendations, but I always get asked for recommendations, so I'll go through those, conclude from there, and then take questions. Hop creep. How do we define hop creep? There's a lot of ambiguity here, so I just want to lay a good definition out. Hop creep is the unintended secondary fermentation that comes from adding hops on the cold side. So when you add hops and you have another fermentation that adds to your normal one, that's hop creep. There are a lot of symptoms of hop creep that get misconstrued as hop creep. So things like quality and safety. So you have diacetyl uptick. That second diacetyl peak that you'll get comes from hop creep. The tank timelines, which can cost you lots of money every day that beer is in a tank. Sometimes those beers can take a month to complete fermentation, and so that can cost a lot of money. CO2 increase and alcohol increase are definitely really impactful, more so in the packaged product, which can put you in trouble with TTB in the US, and also cause exploding cans. The thing that is less talked about is the recipe imbalance. When you have that increased fermentation, you're going to have a lower sugar content that can no longer withstand the amount of hops that you've put in the beer. It's going to have an increased perceived bitterness. That CO2 is also going to cause a different sensory imbalance, as well as the alcohol increase. It's all out of whack. And so that beautiful recipe that you've made is now completely out of balance. So, all as brewers, we are really familiar with utilizing enzymes that are known to come in hops, alpha and beta amylase, limit dextranase, amyloglucidase. We utilize alpha and beta in the mash to cut up that starch and create simple sugars and dextrins. Remember the dextrins, those are important for later. And so you're used to using these enzymes already. You're already familiar with them when you use them from the malt. But then when you add hops into your tank, those same dextrins that you've created to be residual in your beer are now getting cleaved by those same enzymes, creating additional simple sugars that the yeast will then eat, creating more CO2 and ethanol, as well as the diacetyl and other issues. So this is the current basis, the current hypothesis that came out of Oregon many years ago now. But that's all fine and well for the most part when it happens in the fermentation vessel. You get more of an issue when you have it happened in the packaged product. As I mentioned, the alcohol increase, the CO2 increase causing exploded cans, things that are definitely not okay for quality and safety going to your consumers. So I like to throw this slide and the next slide up just because this is how biochemists see kind of the world. This is how we see like beer. The large blobs are going to be enzymes. The things flying around are going to be substrates and products, which in our case would be a dextrin flying in, getting modified by the enzyme, and then flying out as a simple sugar once it is modified. So now into the science that I hopefully will not make too dry. The first thing I wanted to do coming right out of the brewing industry as a brewer, I wanted to create something for brewers. Initially, it was going to be called the cheat sheet for hop creep. That did not go as planned. Every brewer dry hops differently. And so, in order to eliminate that factor, I wanted the only variable to be hop product. And so, I kind of wanted to understand what provided the most and the least amount of creep and what expectations you could get from different hop products, different varieties, growing regions, etc. And so after about 450 fermentations, I have some but not many answers. The main thing that I was measuring is going to be ABV increase. So these are what the fermentations kind of looked like. And then I have to tell you about statistics very briefly. So the only thing you need to know is ANOVA and then Tukey post hoc. And so you want a really small p-value, and it means that you have a difference. And so it will tell you if your Citra T90 is different from your Mosaic T90. Once you have a difference, you then want to be able to see what has the most and least amount of creep. I like visuals. So imagine we have fruit, but you can say this is Citra and Mosaic and Centennial. And then you have a very small p-value. So there's a difference in your fruit. Then you would go into Tukey analysis, and that would place them into groupings. And so you can see this pear is not different from either, but all the citrus fruit is different from that. This will make sense. So the first thing I wanted to see is if you add double the amount of hops, will you have double the amount of hop creep? And the answer is no. This was at 2 pounds per barrel and 4 pounds per barrel. And so that's kind of cool because you can add more hops and not get more hop creep. The next thing I tested was product type, and the Cryo, Noble, and T90 are in a group by themselves, and then you have whole cone sitting again by itself over here. And that's kind of interesting because most people are not using whole cone hops. So the things that you're using to dry hop are not significantly different from each other. And so when you're selecting different product types, you're selecting different parts of the cone, which is important to keep in mind when you're thinking about hop creep. The other thing that was really interesting is if we actually look in on these bars here, the T90 pellets are the most consistent thing to dry hop with when it comes to dry hop creep. And so that means you're getting more consistent results with the most used product that's out there. So growing region, again, we had significant differences, but the things that we're using to create IPAs are all in the same group. So these are not significantly different amounts of hop creep versus something from Central Europe, which had the lowest amount of hop creep, we're not using in an IPA. No one is making a SOTS double IPA. Variety, this slide is very busy, but there are important takeaways. Cascade is multiple years, Centennial was multiple years, and Mosaic was multiple growing regions. And they ended up in the same grouping each time. So Cascade produced the highest amount of creep, even over multiple years. Centennial had the same amount of hop creep over multiple years. And so we talk about this year-to-year variation that does exist, but it's not as significant as we think. The other thing is if we place a bell curve on top, most hops do a medium amount of creep. You have some outliers on the very edges, but most hops, even if I didn't test your favorite one, just gives like a medium amount of creep. So at the end, as a good scientist, you throw all the significant things back into the ANOVA model, and you say, is alcohol increase from hop creep dependent on these things? And the answer is yes, it is. So sadly, there is no cheat sheet, but you can have common varieties and types with consistency. So that T90 giving you a really small error bars there means that there's a lot of consistency with T90 pellets. The hoppy styles use the things that are not significantly different from each other. No one is making whole cone Hallertau IPAs, and those are all very significantly different. So the things you're using for IPAs are not different from each other. Most varieties are in the same group, even if they're statistically significantly different. The most important thing is that all hops exhibit hop creep. All hops and all product types exhibit hop creep. Experiment 2 is on plant secondary metabolites, which you probably know more about from biotransformation studies. They're always talking about glycosidigly bound precursors. Glycosidic is going to be bound to a sugar. And so if we're releasing that aroma compound, we're releasing the sugar as well. So these are anything not needed for primary metabolism. And they have a secondary modification. So plants can't get up and run away when something wants to attack them. The way that they deal with it is having molecules that are ready to go, and then they just need to take off a sugar, which is a really easy mechanism for them. So they use it for a lot of different reasons. Yeah, this is kind of a visual example that you can look at while I get some water. Okay, so linalool, which we talk about, is a glycosidically bound precursor in the plant. So that's a glucose molecule here. That's the beautiful aroma that we love. And now enzymes or acidic pH can break this bond, and you get the free linalool, great for us, the glucose. And we haven't talked about what happens to that glucose. If there is free glucose in wort, it will be fermented. So this pH breakage can happen at the pH of beer, pH of fermentation. And beta glucosidases are not only going to be active within the plant, they're going to be active in microbes and as well as some yeast. So this is kind of my experimental plan. I just took hops, performed an extraction, measured the base sugar, and then I did a incubation with a beta glucosidase that is used in the brewing industry, and then measured that to know the release of these compounds. And so the important thing to know about these measurements is that this is one small sliver of these plant secondary metabolites. There are thousands that exist within the plant that have nothing at all to do with aroma. They just exist and will also be cleaved under these same conditions. So there is a significant increase of plant secondary metabolite glucose released from these enzymes. The big green line on top is the amount of glucose released over the sugar, the free sugar in the hop plant. And the stars just mean that it's a significant difference. And this is the graphic form of that. So we've got cryo, noble, and T90. Glucose is here, and you're looking at the middle bar. So the blue is going to be the enzyme release. Cryo has less green material in it, so it would have less of a difference between those, whereas T90 has that biggest difference because there's a lot, the whole cone is in there essentially. This is all of the varieties, also separated by cryo, noble, and T90. And again, you can see cryo, not that big of a difference other than talus, which is weird. And then T90, again, with those biggest differences between the blue and the green. So there is a significant difference between the different product types and the different plant secondary metabolites. So we're getting a lot of glucose that's just being released within the beer, potentially. Largest increase with T90s, smallest is with those cryo pellets. Again, when you're selecting different product types, you're selecting different pieces of the hop. And so cryo containing those lupulin glands is going to contain less of the plant secondary metabolites that are in there. But is it the biggest contributor? Dun, dun, dun. No. So this is the thing I'm most excited about. It's very cool, I think. Diurnal starch accumulation in plants. So there's something transitory starch. This is going to be really different from the barley starch that you're used to in the malt. This is not as tightly packed, and it's built up throughout the day and then broken down overnight. And the important thing to remember here is that starch is a polymer. It's thousands and thousands of glucose molecules, whereas the plant secondary metabolites were a single glucose bound up to thousands of molecules. But so in order to build starch and to break down starch, you have to have the enzymes that are responsible for hop creep present. So If starch exists in hops, it means that the source of the enzymes is now confirmed to be from hops. Um, so this is kind of what it looks like over the time of a day. This is starch concentration, and then throughout the day, it kind of builds up, and the differences are just different types of cells here, and it breaks down overnight. So, is there starch in hop cones? The answer is yes. So, just simple brewer technique here using iodine. And you can see the blue staining in here means that it's attached to starch granules. And this is actually, when I looked under the microscope, did not know it was stomatogard cells. I just thought it was weird halos. But the blue circles here are the stomatogard cells, and it actually helps open and close those stomata. So I, being a scientist, have to add numbers to it and can't just tell people that there's starch based on iodine. So I did that. There's these numbers, but this is better. So these are just random samples I had in lab that I wanted to test immediately to prove that there was the starch there. I don't have time data associated with these numbers. So I did 2 T90s, 2 cryos, and 2 whole cones of different varieties. And you can see that there is an increase in glucose after incubation. So there's upwards of 10% of material that is potential sugar that will be fermented when you dry hop. If you want to read more about it, it just got published last week. So now we need to rethink about the components of hop grape, right? We've always been told it's the enzymes, it's the enzymes, it's the enzymes, which is true. Those exist, and that's also what would then be breaking down the starch that is getting added. There's free simple sugars, that's about 2 to 3% usually within starch or within the hops. But the new components that we also need to think about are going to be these plant secondary metabolites that can be cleaved by the acidic pH of beer. And then more importantly is this starch, which is completely unknown about how much that even gets to. I don't know. We'll figure it out. So my current experiment is doing this diurnal starch experiment. And so I went out in the hop fields in Yakima, and every 4 hours for 24 hours, picked hops. And that's why you see a lot of pictures at night, because I was out there very scared in a hop field. So I'm going to take those samples. I will run the same HPLC on it and hopefully see that gradual increase over the day, the breakdown overnight. And then I'll also do benchtop fermentations along with that to see if there, with the increase of starch, we also see an increase in the fermentation from hop grape. And I will also try and measure, if I have time, the enzymes associated with that to see, as the starch is building, are the enzymes increasing or decreasing over that time? And so, in conclusion, these are all the potential sugar sources that you're getting from hops on the cold side. But the cool thing is that we confirmed that the enzymes are definitely from the hops. Microbial could still be there, but it is from the hops themselves. And yeah, there's a lot of sugar that you're adding into your wort. So, recommendations. Everyone needs to do what works for them, period. I would like to say that. The most important thing is what works for you. But I will talk about when I showed those videos of the enzymes moving around, temperature is just a measure of molecular movement. So how fast those molecules are moving around. The more molecules are moving around, the more they can bump into each other and perform a reaction. If you're at a warmer temperature, theoretically, those molecules are moving faster around. You have the enzymes coming down in there, you have the sugars coming in, bumping into the yeast. Everyone's doing their thing. Also, the yeast is still active, it's still fermenting, still doing all of the business it needs to. Also, diacetyl uptake, faster at higher temperatures, we know that. So warmer can be better for clearing hop creep faster. Cold side, obviously, I know people do that, and I know Hernan does that, and his beers are A1, so good. But there's less yeast going to be in solution. You're going to have yeast in a more dormant, sleepy stage. It's going to be at the bottom of the tank. And again, that molecular movement is much slowed at that point. So it's going to take a lot more time. So time is always the answer with hop creep. You need to let it do what it's going to do, or it's going to happen in package, and then you're going to be giving your consumers diacetyl beers. You're going to be giving them beers with higher CO2, higher alcohol. Not a good time. So the other answer is healthy yeast. We all know that. They want to make more valine. They're feeling really sad about it. And then they make a bunch of diacetyl. People are using ALDC. Doesn't have anything to do with the yeast. I flipped through that quickly because if you want to hear more about it, Vinny and I talk about it on the session, which is a podcast. It is in English, so I'm sorry. But you can add zinc on the cold side. That's a big thing that's come out in the past few years. Making sure you have really healthy, really active yeast that's going to chew up all that new sugar, clear the diacetyl, and get you through that secondary fermentation. Mid-fermentation dry hopping, a lot of people are against because how do you harvest your yeast? But I already solved, I'm kidding. Sometimes you can shoot the yeast out of the top of the tank like this. And this is like, even though this looks like a mess, it's really, really healthy, beautiful, delicious yeast. And so I found out a way to capture that and repitch it so you can dry hop on day 2, day 3 of fermentation, and still harvest yeast without having it ever touch that hop material. So there are concerns about micro, but I tested it and it's completely safe if you follow the protocol. I don't know if I went fast, and I'm sorry if I did. Yeah, I just want to thank Vinny and Russian River, super supportive, YCH and Hophead Farms. If you have questions, please feel free to reach out. Yeah, I love talking about hops and hop creep, so come find me.
Levante la mano, ¿quién le parece que Jessica fue medio rápido? Bueno, pero aprovechémosla. Yo tengo la suerte de haber visto la presentación antes y me llevó un montón de tiempo leerla detenidamente. Y claro, es una investigadora de nivel alto, trabaja con un equipo de trabajo de nivel alto, nos metió bastante estadística en el medio, test de Tukey y ANOVA y todas cosas que son muy simples para los investigadores y no tanto para nosotros, no estamos tan acostumbrados. Lo bajó a tierra lo más que pudo con peras y manzanas, pero el post-almuerzo no estuvo exactamente fácil. Así que propongo que la aprovechemos y que le hagamos preguntas sobre Hop Creep y estoy seguro de que si le preguntamos algo que estaba perfectamente explicado en alguna diapo, no va a tener ningún problema en decirnos, ok, te lo explico de vuelta. So probably some of the answers, some of the questions could be absolutely related to one slide, but I'll kindly answer and take it down to earth so we can understand your very fast and very high level talk. Thank you very much. You know, after lunch in Argentina, it's like, well, we have some troubles. Bueno, ¿quién se anima a preguntarle algo sobre Hop Creep?
Who dares to ask something to Jessica about hop creep?
Lo que quedó claro es que los PLT90, que son los que usamos todos, son candidatos a eso. Arrancamos allá.
Hola, acá está. Bueno, buenas tardes, gracias. Tengo una pregunta y es si estudió algo de hop creep utilizando levaduras de bajo alcohol que generalmente metabolizan, muchas de las que hay hoy en día comercialmente, metabolizan azúcares cortos, entonces cuando ponemos el lúpulo puede generar un efecto. Entonces si hizo algún estudio usando esa levadura o si vio que depende de la levadura, el hop creep puede ser más frecuente o menos frecuente. Bueno, nada, si en la experiencia tiene algo para contarnos.
Buenísimo, gracias. Have you ever tried in some of your experiments with low alcohol yeast? No.
Sorry. Sorry.
Siguiente.
Sorry. No.
¿Cómo? Sí, sí, había que eficientizar el tiempo.
Hola, mi pregunta va un poco más asociada al tema de la levadura, pero quería preguntarle cómo ella podría aconsejar a un cervecero para identificar que la levadura está completamente viable para llevar a cabo una nueva fermentación y que no ocurra el hop creep como mencionó.
Okay. How would you help a brewer to be sure that the yeast has very high viability and there is low possibility of causing hop creep in the next batch?
Low viability to make sure it doesn't cause hop creep in the next batch. Well, one, hop creep is still going to happen in the next batch. It will always happen. Okay, yeah.
It's working. I don't
Yeah.
have to work.
Oh, I
Yeah.
was wondering what you were looking at. Okay.
Sorry.
Yes, so hop creep will always happen. So yes, making sure your yeast is really healthy is important. So when you are harvesting, if you can do a viability count and know that you're pitching at good quantities, to making sure there's enough fan in your wort, which I know is not always the case, and then making sure you're putting nutrient or zinc on the cold side, all those things that are kind of like true to the 101s, as Matt says, like making sure that your yeast is, if you had a sluggish fermentation in that first one, I probably wouldn't use that one to try and get through an IPA. Or if you used it in a high gravity, high alcohol beer, probably not going to use that one. Use the one that you just did on like a really nice little blonde ale or something, the one that's earlier in your generations, I suppose. But yeah, I mean, just the basics of making sure you're using good nutrients, good wort. Unfortunately, that's all. I'm not the yeast person. Maybe ask like Richard or something. I just know it needs to be healthy,
Thank you, Jesse. Okay.
Hola.
Sí, faltaba agregar algo porque el bot anduvo ahí, pero bueno.
Hola.
Sí.
Bueno, un poco con el gráfico que mostró de la presencia de almidón durante el día, medio les pasa la pelota a los lupuleros. Quería preguntarle si, si es el siguiente paso de la investigación es probar cosechas a diferentes horarios del día y ver esa concentración cómo afecta al hop creep. Gracias.
Ok, la dejamos a Jesse. Yo tengo mi teoría, pero within your experiment, when you were measuring starch content in different times of the day, are you expecting we as hop growers to change our harvest moment?
Absolutely not. No, I think the responsibility of hop growers is to make a beautiful, good hop. I think it is the responsibility of brewers to deal with hop creep. That is how I feel about it. Maybe other people are angry at that, but I think you make the beautiful smelling, good alpha varieties when we need it. You make the good hop. We deal with the raw materials, right? We're not saying to the maltsters, oh, you need to. Well, we have specifications, but we can't say also deal with hop creep. I think that's our responsibility as brewers. So in the US, they harvest 24 hours a day. Because when I was out there at 3 a.m., there were hop trucks all around me harvesting all night.
And also a big kiln is made with hops from many different hours during the night and during the day.
It's all amalgamated. It's all put together. So
Less work for us.
less work for you guys.
Thank you.
Una pregunta, dos.
Trabajo para ustedes.
Preguntar sobre en el fondo, el incorporar zinc en el cool side tiene que ver con darle la vitalidad o que la levadura esté lo suficientemente sana para que vaya a reabsorber el diacetilo. Por lo tanto, va más la estrategia en ese sentido, más que evitar que se produzca. No sé si se entiende claramente la pregunta. Y lo otro es las alternativas de productos que existen hoy día como el Maturex. Si lo ha chequeado para saber efectivamente que funcione.
Vamos por partes. Gracias. The zinc addition is related to avoid the releasing of undesirable compounds, or is related to the reabsorption of that undesirable compounds?
So zinc is important for yeast health because it's used as a cofactor on a lot of enzymes. So it would essentially attach to the enzyme, causing it to be a different shape, and then it would be able to do its process better. And so it's used in hundreds of enzymes throughout all of metabolism, primary and secondary. So it's used in a lot of different things for, I don't know if specifically it has an attachment on like a diacetyl reductase, but it is used for a lot of different things within the yeast cell.
Thank you. ¿Me repetís el compuesto de la segunda pregunta, porfa? Did you ever try the product Maturex? Maturex? ¿Cómo? Perdón. No escucho. O the enzyme ADLC?
ALDC, yeah. I've tried all of them. I think because at my last brewery we were doing mid-fermentation, so we were dry hopping day 2, at the latest day 3. That diacetyl uptick that happened from your normal curve was also almost coinciding with that first curve. So by the time, the thing we were waiting on at the end was not diacetyl, it was terminal gravity. So I've used ALDC. I know a lot of people use it. It's used almost religiously in the US because there's a misconception that that is hop creep, but it is a symptom because if you're dry hopping cold and you are just waiting out the diacetyl uptake, I wouldn't be confident that you have completed fermentation. And that's dangerous in and of itself. So yes, those products are good to use to clear the diacetyl, but don't forget about the fermentation. That's the important piece of hop creep.
Thank you.
Bien.
Matt, your turn.
So thank you so much for doing this work, by the way. It's just amazing to have real science being applied to these things because there's a lot of alchemy applied. I was just curious because the Hop Quality Group had done work in kiln study, lowering kiln temperatures, and then there's some level of guilt that potentially that lower kiln temperature was leaving behind more enzymatic activity. Have you yet looked at the temperature that denatures these enzymes in hops?
So
Matt dice que con el Hop Quality Group ellos estuvieron investigando secar el lúpulo a menor temperatura y entonces la pregunta era, ¿cuál era la pregunta, Rick? Sí, ahí me perdí con el team. Ok. La pregunta era, me confundió el denature con el teenager. Perdón, en serio. La pregunta era si Jesse, a través de sus experimentos, pudo encontrar una temperatura a partir de la cual se desnaturalizan estas enzimas causantes o co-causantes del hop creep.
So all enzymes theoretically will be denatured at a point. And I'm aware of this, talked to Vinny about this too. And hop creep still existed even before we did that lowering of kiln temp. It has been exacerbated. It seems it increased, but I don't know if it's entirely based on the kiln temperature. I don't think we can say that exactly. So yes, there is a temperature that will denature them, but I think at that point, the return of what we would get back on the hops would be really sad. It would be a really, really gross thing I wouldn't want to put in my beer, is what I think. So,
De lo que yo entendí, la respuesta es no. No hay una temperatura. Es como que en general el secado del lúpulo desnaturaliza bastante, pero no lo puede afirmar con seguridad de que, bueno, a partir de tal temperatura se desnaturaliza. O sea que sigue ocurriendo.
Una por acá.
Fácil, porfa.
Creo que es fácil. O sea, es tratar de ver si ella en sus estudios tiene algún número práctico de una cantidad de lúpulo mínima, supongamos en un dry hopping caliente típico de Cascade, por hacerlo fácil. Algún número de cantidad mínima en gramos por litro, 1 gramo por litro, 2 gramos por litro, para asegurar que ese hop creep suceda y finalice por completo bien la fermentación, digamos. O sea, si hay un umbral mínimo que ella haya reconocido, ¿se entiende?
Gracias. Porque además lo tengo que pasar a pounds per beer barrel.
Sí.
Have you find a minimum amount of hop dose regarding a hot dry hop to be sure that y ahí me perdí.
De que el hop creep va a suceder,
¿Qué,
digamos.
qué? That the minimum amount of hop dose during a hot dry hop to be sure that you will have hop creep. Can you tell us an amount in pounds per barrel or grains per liter or whatever you want?
Okay.
We will try to.
Yeah. Okay, so the lowest amount of hops that you could use that you would not get hop creep, is that right?
No, I
No.
want to have hop creep.
Entonces, I believe the question that he gave was, what is the minimum amount of hops per barrel that you would recommend, or that exists for hop creep to exist, and then I believe to finish out. Like, that is the question. I don't know if it's easy
Sí,
to
sí, ese es.
understand. Right, but I'm saying that was the question.
Está bien, está bien. No, pero-
O sea, la revemos. La
no,
pre-
no importa, ya está. O sea, porque nosotros queremos asegurarnos que eso suceda y que la fermentación complete, ¿no?
Para que estoy a dos conversaciones.
The minimum amount that you would get hop creep. Okay. I mean, I've seen it at 1 pound per barrel, so I think I've seen a lot at 1 pound per barrel. I think it's more dependent on product type. If you're using Cascade, you could because that's such a high creeper, I would say you could use a small amount of Cascade and still see hop creep, whereas if you used triple the amount of Strata, maybe you wouldn't see hop creep. I think it's so dependent on product type and variety and all the other things that I mentioned. I would say I've definitely seen it at 1 pound per barrel. I am sure it happens below that too. And then at that point, are you getting the benefits of aroma and et cetera out of the beer? I think it would be a little dead. So I think at the value of you getting aroma, you would not get it if you are using low enough that you're not getting hop creep. It is, it's so dependent, and there's so much that still needs to be figured out with the enzymes and the starch and the sugar that I don't know. I have no idea really.
Ok.
Está bien.
So, la respuesta corta sería que, además, mirando la presentación, ella
No, sí,
probó en el experimento dosis 1 de 1 pound per barrel, es decir, 3,88 gramos litro, y dosis 2. Y en las dos lo encontró, con lo cual no tendría una respuesta en base a los datos que mostró. Thank you.
Thank you.
No, your experiment was okay. You try 1 pound per barrel and 2 pound per barrel, 2 and 4, and in both cases you find it so well. ¿Una más? La atajamos. Sí.
¿Me escuchas bien igual?
Sí.
Y si tiene como un comentario para hacer en base a distintas cepas de levadura utilizadas relacionadas con el hop creep.
So, what can you tell us regarding different yeasts?
So there was a study that came out before my time at UC Davis, where someone tried, I don't know, a lot of different yeasts and measured hop creep. And there were some that had slightly less but the ones that had slightly less produced garbage beer. So that's
Thank you.
okay.